In this video, we are going to learn how to solve linear programming problems using the graphical method. Linear programming problem, graphical method. Okay guys, in this video we are going to solve two problems: maximization problems involving two constraints and maximization problem involving three constraints. Question 1. Maximize z is equal to 6s1 plus 8s2 subject to 5s1 plus 10s2 is less or equal to 60 and 4s1 plus 4s2 is less or equal to 40. s1 and s2 is greater or equal to 0. Okay guys, this is a maximization problem. Before we solve this question, I would like us to know the meaning of linear programming. Linear programming is an optimization technique for a system of linear constraints and a linear objective function. We solve linear programming basically for two major reasons: to find the best way we can combine the available resources in order to 1. To minimize the total cost of production, and 2. To maximize profit. So in this question, we want to maximize z, which is the objective function, 6s1 plus 8s2, subject to the first constraint, 5s1 plus 10s2 is less or equal to 60, and 4s1 plus 4s2 is less or equal to 40. s1 and s2 is greater than 0. This is the set of non-negative restrictions. Z is the objective function. S1 and S2 are the decision variables. We have so many ways of solving linear programming. We can solve using the graphical method, the simplest method, the dual simplest method, the big M method. In this question, we are going to be solving using the graphical method. We use the graphical method when we have not more than two decision variables. In this question, we have only S1 and S2, which is two decision variables. So we can solve using the graphical method. Solution. Look at the first constraint. 5s1 plus 10s2 is less or equal to 60. So write that first constraint here, removing this less than sign. So 5s1 plus 10s2 is equal to 60. Notice it is no longer less or equal to 60. It's equal to 60 here. So you want to find s2 when s1 is equal to 0. So when s1 is equal to 0, you want to find s2. So 5 multiplied by 0 plus 10s2 is equal to 60. 5 multiplied by 0 is 0. So 10s2 is equal to 60. S2 is equal to 60 divided by 10. 60 divided by 10 gives us 6. So S2 is equal to 6. So when S1 is equal to 0, S2 is equal to 6. When S1 is equal to 0, S2 is equal to 6. When S2 is equal to 0, you want to find S1. When S2 is equal to 0, you want to find S1. So 5x1 plus 10 multiplied by 0 is equal to 60. So 5s1 is equal to 60. S1 is equal to 60 divided by 5. 60 divided by 5 gives us what? 12. So when S2 is equal to 0, S1 is equal to 12. So when S2 is equal to 0, S1 is equal to 12. So go to the second constraint. 4s1 plus 4s2 is less or equal to 40. Write it here. 4s1 plus 4s2 is equal to 40. So remove this less than sign and leave the equal sign. So 4s1 plus 4s2 is equal to 40. You want to find s2 when s1 is equal to 0. So when s1 is equal to 0, you want to find s2. 4 multiplied by 0 plus 4s2 is equal to 40. 4 multiplied by 0 is 0. So 4s2 is equal to 40. S2 is equal to 40 divided by 4. So 40 divided by 4 gives us 10. So when S1 is equal to 0 for the second constraint, S2 is equal to 10. Similarly, when S2 is equal to 0, we want to find S1. So when S2 is equal to 0, 4S1 plus 4 multiplied by 0 is equal to 40. So 4 multiplied by 0 gives us 0. 4S1 is equal to 40. So S1 is equal to 40 divided by 4. 40 divided by 4 gives us what? 10. So when S2 is equal to 0, S1 is equal to 10. As we can see, we have found 4 points here: 0, 6, 12, 0, 0, 10, and 10 and 0. So from the first constraint, we have 2 points: 0 and 6, and 12 and 0. And from the second constraint, we have 2 points: 0 and 10, and 10 and 0. We can plot graph using these points. We want to plot these points in a graph. When S1 is equal to 0, S2 is equal to 6. So When S1 is equal to 0, S2 is equal to 6. Look at the point here. S1 is equal to 0 and S2 is equal to 6. And when S1 is equal to 12, S2 is equal to 0. When S1 is equal to 12, S2 is equal to 0. So look at the point here. When S1 is equal to 12, S2 is equal to 0. So we draw the first line here. When S1 is equal to 0, S2 is equal to 10. So when S1 is equal to 0, S2 is equal to 10. Look at the point here. When S1 is equal to 0, S2 is equal to 10. And when S1 is equal to 10, S2 is equal to 0. When S1 is equal to 10, S2 is equal to 0. So look at the point here. So we join the 2 points. We want to find the feasible region. So go back to your question and check the constraints. Look at the first constraint. 5s1 plus 10s2 is less or equal to 60. As you can see here, is less or equal to. It means that the feasible region is below the line. So look at the line for the first constraint. It means that the feasible region is below this line. Means that this outer space is not the feasible region. So this space is here is not the feasible region. Look at the second constraint. 4s1 plus 4s2 is less or equal to 60. It means that the feasible region is below the line. That is, the lines above are not the feasible region. So look at the line for your second constraint. The space is above is not the feasible region. So it means that this space below here forms the feasible region. So here is the feasible region. So your feasible region is divided by 4 points. Point A, point B, point C, and point D. So point A is 0, 6, 0, 6. Point B is 0, 0. So when S1 is 0, S2 is 0. Point C, when S1 is 10, S2 is 0. And point D. So we want to find this point D, S1 and S2. Which lines form this point? Is this first constraint and second constraint. So get the equations of the line which forms this point. So look at the equation for the first constraint. 5s1 plus 10s2 which is equal to 60. For the first constraint, look at the first line here. 5s1 plus 10s2 is equal to 60. And look at the second line here. The equation for the second line is 4s1 plus 4s2 is equal to 40. So you want to find s1 and s2 from these two equations. Let's make s1 subject of formula in the first constraint. So s1 is equal to 60 minus 10s2 all over 5, which is equal to 60 divided by 5 gives us 12 minus 10 divided by 5 gives us 2s2. So put this value inside the second equation. So 4 bracket 12 minus 2s2, 12 minus 2s2 plus 4s2 is equal to 40. 4 multiplied by 2 gives us 48 minus 4 multiplied by 2 gives us 8s2 plus 4s2 is equal to 40. So minus 8s2 plus 4s2 gives us minus 4s2 is equal to 40 minus 48. Minus 48. So minus 4s2 is equal to 40 minus 48 is minus 8. S2 is equal to minus 8 over minus 4, which is equal to 2. So S2 is equal to 2. So when S2 is equal to 2, we want to find S1. We know that S1 is equal to 12 minus 2S2. So S1 is equal to 12 minus 2S2. S2 is equal to 2. So 12 minus 2. So S1 is equal to 12 minus 2 multiplied by 2 gives us what? 4. S1 is equal to 12 multiplied by 4, 8. So when S1 is equal to 8, S2 is equal to 2. So when S1 is equal to 8, S2 is equal to 2. We want to find the optimal solution now. Look at the objective function. Z is equal to 6s1 plus 8s2. Maximize Z is equal to 6s1 plus 8s2. So Z is the objective function now. ZA is equal to 6, S1 is 0, multiplied by 0, plus 8, S2 is 6. 6 multiplied by 0 is 0, and 8 multiplied by 6 gives us 48. 6 multiplied by S1, 0, plus 8 multiplied by S2, 0, is equal to 0. 6 multiplied by S1, 10, plus 8 multiplied by S2, 0, is equal to 6 multiplied by 10 is 60, plus 0 is 60. And look at the point D. 6 multiplied by S1, 8, plus 8 multiplied by 2. So 6 multiplied by 8 gives us 48, plus 8 multiplied by 2 gives us 16. 48 plus 16 gives us 64. So as you can see, the first point Z gives us 48, the second point Z gives us 0, the third point Z, which is the objective function, gives us 60, and the fourth point D, Z, which is the objective function, gives us 64. The value of Z is maximum at the point 8 and 2, which gives us 64. We are searching for maximization, so the Z value is maximum for the corresponding point. S1 is equal to 8 and S2 is equal to 2. Z optimum is equal to 64. Let's take the second example. Question 2. Maximize Z, which is the objective function. 25S1 plus 15S2, subject to the first constraint. 10S1 plus 20S2 is less than or equal to 100. 16S1 plus 4S2 is greater than or equal to 32. And 6S1 minus 4S2 is greater than or equal to 12. We can solve this exactly the way we solved the first question, which is maximize Z equal to 6S1 plus 8S2. Notice that this question have only two constraints, 1 and 2. But the question 2 have three constraints, 1, 2, and 3. Solution. Look at the first constraint here. 10S1 plus 20S2 is less or equal to 100. So 10S1 plus 20S2, remove the less than sign, equal to 100. So when S1 is equal to 0, we want to find S2 when S1 is equal to 0. So 10 multiplied by 0 plus 20S2 is equal to 100. 10 multiplied by 0 is 0. So 20S2 is equal to 100. S2 is equal to 100 divided by 20. 100 divided by 20 gives us 5. So when S1 is equal to 0, S2 is equal to 5. When S2 is equal to 0, you want to find S1. 10S1 plus 20 multiplied by 0 is equal to 100. S1 is equal to 20 multiplied by 0 is 0. So S1 is equal to 100 divided by 10. 100 divided by 10 gives us 10. So when S2 is equal to 0, S1 is equal to 10. When S2 is equal to 0, S1 is equal to 10. Go to the second constraint. 16S1 plus 4S2 is equal to 32. When S1 is equal to 0, so 16 multiplied by 0 plus 4S2 is equal to 32. S2 is equal to 32 divided by 4. So 32 divided by 4 gives us 8. So when S1 is equal to 0, S2 is equal to 8. When S1 is equal to 0, S2 is equal to 8. And when S2 is equal to 0, you want to find S1. When S2 is equal to 0, you want to find S1. 16S1 plus 4 multiplied by 0 is equal to 32. S1 is equal to 32 divided by 16. So 32 divided by 16 gives us what? 2. So when S2 is equal to 0, S1 is equal to 2. For the third constraint, 6S1 minus 4S2 is equal to 12. When S1 is equal to 0, when S1 is equal to 0, we want to find S2. So 6 multiplied by 0 minus 4S2 is equal to 12. So S2 is equal to 12 divided by minus 4 is equal to minus 3. So when S1 is equal to 0, S2 is equal to minus 3. And when S2 is equal to 0, we want to find S1. When S2 is equal to 0, 6S1 minus 4 multiplied by 0 is equal to 12. So S1 is equal to 12 divided by 6 is equal to 2. So when S2 is equal to 0, S1 is equal to 2. When S2 is equal to 0, S1 is equal to 2. We now have 6 points. The first point 0 and 5, the second point 10 and 0, the third point 0 and 8, the fourth point 2 and 0, the fifth point 0 and minus 3, and the sixth point 2 and 0. We can plot these points in a graph. From the first constraint, when S1 is equal to 0, S2 is equal to 5. So when S1 is equal to 0, S2 is equal to 5. Look at the points here. And when S1 is equal to 10, S2 is equal to 0. When S1 is equal to 10, S2 is equal to 0. Look at the points here. From the second constraint, when S1 is equal to 0, S2 is equal to 8. When S1 is equal to 0, S2 is equal to 8. And when S1 is equal to 2, S2 is equal to 0. When S1 is equal to 2, S2 is equal to 0. And from the third constraint, when S1 is equal to 0, S2 is equal to minus 3. When S1 is equal to 0, S2 is equal to minus 3. This point. And when S1 is equal to 2, S2 is equal to 0. When S1 is equal to 2, S2 is equal to 0. This point. So you join it this way. We want to find the feasible region now. Look at the line for the first constraint, the line for the second constraint, and the line for the third constraint. From the question, the first constraint, 10S1 plus 20S2 is less or equal to 100. Less or equal to, it means that the feasible region is below the line. So look at the first line, the feasible region is below this line. It means that the space is above this line is not the feasible region. So this space is here is not the feasible region. From the second constraint is greater. If it's greater, it means that above is the feasible region. That is, above is the feasible region, means that below the line is not the feasible region. Look at the second line here. So below the second line is not the feasible region. And look at the third line. 6S1 minus 4S2 is greater or equal to 12. Is greater, it means that the feasible region is above. The feasible region is above, means that below is not the feasible region. Therefore, here is not the feasible region. Therefore, look at the feasible region here. We now want to find the points that bound this feasible region. Look at the point that bound this feasible region. Point A, point B, and point C. And point A is 2 and 0. S1 is equal to 2 and S2 is equal to 0. So point A is 2 and 0. Point B, when S1 is equal to 10, S2 is equal to 0. So when S1 is equal to 10, S2 is equal to 0. And point C, we want to find point C. Point C, look at point C here. Point C is an intersection of two lines. The first constraint, the line formed by the first constraint, and the line formed by the third constraint. So you can solve the equation of the first constraint and the third constraint simultaneously. Look at the equation of the first constraint. 10S1 plus 20S2 is equal to 100. So 10S1 plus 20S2 is equal to 100. And look at the equation for the third constraint. 6S1 minus 4S2 is equal to 12. 6S1 minus 4S2 is equal to 12. From the first equation, we can make S1 subject of the formula. S1 is equal to 100 minus 20S2 all over 10. So 100 divided by 10 is equal to 10 minus 20 divided by 10 is 2. 2S2. So putting this inside the second equation, 6 bracket 10 minus 2S2 minus 4s2 is equals to 12. 6 multiplied by 10 gives us 60. 6 multiplied by minus 2 gives us minus 12s2 minus 4s2 is equal to 12. So 60 minus 12s2 minus 4s2 gives us minus 16s2 is equal to 12. So minus 16s2 is equal to 12 minus 60 minus 16s2 is equal to minus 48. Therefore, s2 is equal to minus 48 divided by minus 16. So when you divide minus 16 by minus 48, you are going to have 3 as the answer. So s2 is equal to 3. So if s2 is equal to 3, s1 is equal to 10 minus 2s2. So s1 is equal to 10 minus 2 s2 3. Therefore s1 is equal to 10 minus 2 multiplied by 3 is what? 6. So 10 minus 6 gives us 4. Therefore s1 is equal to 4 and s2 is equal to 3. So s1 is equal to 4 and s2 is equal to 3. Let us find the optimum solution. Look at the objective function. Z is equal to 25s1 plus 15s2. At point A, Z is equal to 25s1, which is equal to 2, plus 15s2, which is equal to 0. So 25 multiplied by 2 gives us 50. At point B, the objective function Z is equal to 25 multiplied by 10 plus 15 multiplied by 0. 25 multiplied by 10 gives us 250. And at point C, Z, which is the objective function, is equal to 25 multiplied by 4 plus 15 multiplied by 3. 25 multiplied by 4 gives us 100 plus 15 multiplied by 3 gives us 45. So 100 plus 45 gives us 145. Because we are solving for maximization, at the point 10 and 0, we have the maximum objective function 250. Therefore, the z value is maximum for the corresponding point. S1 is equal to 10 and S2 is equal to 0. And the optimum solution is 250. Always record that your feasible region is the region where you have the minimum cost of production or the maximum profit. And when you have the less or equal to, the feasible region is below. Whereas when you have the greater or equal to sign, the feasible region is above the line. Okay guys, in our next video, we are going to solve 2 questions on minimization. The first involving 2 constraints and the second involving 3 constraints. I hope the video was useful. Please subscribe to my channel. See you in the next video.